Hello everyone, welcome back to Advent of Code 2025. Going to be doing day 8 today. I guess this is old news for you guys, but I just found out that I released day 6 out of order. It came in between days 3 and 4. Oh well. So, I guess by now, if you're watching all these, you know about that, but I just found out and I'm a little bit annoyed. So move on to day 8, Playground. Equipped with a new understanding of teleporter maintenance, you confidently step onto the repaired teleporter pad. You rematerialize on an unfamiliar teleporter pad and find yourself in a vast underground space which contains a giant playground. Across the playground, a group of elves are working on setting up an ambitious Christmas decoration project. Through careful rigging, they have suspended a large number of small electrical junction boxes. Through careful rigging, there's junction boxes hanging from, like, cables and stuff. Okay. Their plan is to connect the junction boxes with long strings of lights. Most of the junction boxes don't provide electricity. However, when two junction boxes are connected by a string of lights, electricity can pass between those two junction boxes. The elves are trying to figure out which junction boxes to connect so that electricity can reach every junction box. They even have a list of all of the junction boxes' positions in 3D space, your puzzle input. Okay. Describes the position of 20 junction boxes, one per line, XYZ, fine. To save on string lights, the elves would like to focus on connecting pairs of junction boxes that are as close together as possible according to straight line distance. Okay, so we're not talking Manhattan distance. We're actually talking like the square root. Or is it? Well, there's a link to a Wikipedia article on Euclidean distance. What is the distance between points in 3D space? If I click this link, it'll tell me, but I want to think about it for a bit first. By connecting these two junction boxes together, because electricity can flow between them, they become part of the same circuit. After connecting them, there's a single circuit which contains two junction boxes, and the remaining 18 junction boxes remain in their own individual circuits. Now, the two junction boxes which are closest together but aren't already directly connected are blah. After connecting them, since blah is connected to another junction box, there's now a single circuit which contains three junction boxes. The next two aren't part of the same original circuits. There's 3 and 2. Okay. The next two are already in the same circuit, so don't connect them. After making the 10 shortest connections, there are 11 circuits. Okay, what is the word for a circuit? What if we make... Okay, it's just a coincidence that there's now one more circuit than connection. Because every time we connect things, we're reducing the number of circuits, not increasing it. Because each junction box starts out on its own circuit. Okay. Multiplying together the size of the largest. Okay. Connect together the 1,000 pairs of junction boxes which are closest together. So, are we supposed to connect them and then nothing happens? Or are we supposed to skip connecting them and they don't count? Well, okay, here we've made 10 connections, supposedly, right? And we should be able to count how many actual connections, how many junction boxes pairs were connected. There must have been... Well, no. Okay. There are 4 non... So what I want to find out is, like, this kind of redundant connection. Are you supposed to count this as one of the 1,000 or not? So this one is redundant. So if we can count 10 non-redundant connections here, then we'll know that we were supposed to skip these and not count it. If there are fewer than 10 non-redundant, then we must be including the redundant ones in the count of 10. So here, one circuit contains 5 junction boxes. That means there are 4 non-redundant connections in here. There are 3 more non-redundant connections in here. That's 7. 2 more that contain one connection each. That's 9. Okay. So there are only 9 non-redundant connections among these 10. So this one here does count as one of the 10 that we did. Well, I mean, I know that, like, there are well-known methods for, you know, finding the k nearest neighbors in an n-dimensional space. I don't know what they are, but they exist. This also sort of reminds me of a spanning tree. Like constructing a minimum spanning tree, right? But that requires a graph, which means we would have to also, we're not actually building a tree. We're just connecting 1,000 nodes. So, but anyway, if we wanted a minimum spanning tree, we would need to have a graph where we draw in all the edges between every pair of nodes and label them with their weight. So it would be an n-squared proposition. That's probably fine. There probably aren't a billion lines in my input file, so we could handle that. Wouldn't that be something? But it's not... We're not actually computing a minimum spanning tree, so that's not the right idea. We're finding nearest neighbors in a graph. So... Okay, and so what's, like, the Euclidean distance in 2-dimensional space is the square root of the sum of the squares. In 3-dimensional space, is it the square root of the sum of the squares or the cube root of the sum of the squares? Well... Let's actually do a little bit of arithmetic on paper here. You know, not real paper, but rather than look this up, I want to think about it a little bit. So we have 3 points, A, B, and C. We want to measure... No, we have 2 points, A and B. But they differ on 3 axes. They have a delta x, a delta y, and a delta z. Right, we can imagine that A is at the origin without loss of generality, right? And we're measuring to another point, P. And so we could just talk about x and y and z, and that's the difference from A to B in that dimension. So what would this be? We could reduce this to a 2-dimensional problem, right? By figuring out, like, xy is the square root of x squared plus y squared. And then, like, say, xyz is the square root of xy squared plus z squared. Isn't this, like, correct and also not something I've ever heard of, so certainly wrong? What's wrong with this reasoning? I ain't ever heard of someone measuring three-dimensional distance in this way. Well, okay. So xy squared, though... Okay, this is why. Because there's simplification to do. xy is the square root of something. So xy squared is just that thing, which means it's x squared plus y squared plus z squared. This I've heard of. Okay, great. So that must be the Euclidean distance between 2 points in three-dimensional space. And that's what I thought it was. Cube root didn't sound right, but I couldn't convince myself that square root was right either. But now I've derived it, and I see why it is what it is, and I believe in it. So great. Just to be super duper sure, though, let's go click on that link to straight line distance on Wikipedia. Distance, using the Pythagorean theorem, which I guess is what I just did. In a Euclidean space, 1 dimension, 2 dimensions, in higher dimensions. Yeah, it's the square root of the sum of the squares of the distance in each dimension, which is what I concluded. So let's go look at the input, I guess. How big is it? Oh, I'm in the wrong... 1,000, yeah. So 1,000 squared is totally doable. We could easily compute the distances between all of these points. And then the algorithm we're supposed to use is just to pick the 1,000 cheapest connections to make. Right? And then make them. And determine how many actual connections we made. Or how many circuits there are. So we have kind of a there's a well-known algorithm for if you have like a disconnected series of nodes and you want to join them up together. That I think I did in 1 year of Advent of Code, and I've done it in the past in like a different language, I think. I remember not finding it that straightforward in Haskell because it sort of relies on mutation as you go, and maybe I wasn't as happy doing it in the state monad or something. But let's look up here Tarjan's union find algorithm on Wikipedia, please. The disjoint set data structure. Just waiting for it to load. Having a terrible internet at the moment, apparently. Here we go. It is Tarjan, isn't it? Yeah. Okay, so and it's like unbelievably efficient at all the operations it needs to do. Right, inserting Search. What do you mean search? And what is A? Is A Ackerman? That can't be right. That's alpha. Okay, I don't know what alpha is, but it doesn't really matter. So it's really good at merging sets. And finding a representative member of a set, which I think is the search operation in a sense. Yeah, union and find in like constant time. Oh, alpha is inverse Ackerman. That's why it's so fast. Okay. So it's almost constant, but there's this extremely small factor. All right, fine. Do we want to implement this today? Or do we want to just go borrow something from Hackage? Is it... It's, as you can see, of course, like most algorithms you look up on Wikipedia, it focuses on mutation. It assumes that every node has a few mutable pointers. And this is not impossible to do in Haskell, right? You could use ST, for example, to actually get mutation or state to simulate it. But it's kind of gross to have everything be an STREF. Ideally, you would just have one or two small places where you mutate things. Like, I think it would be reasonable, for example, to just have one STREF for each whole object rather than like 3 pointers within it. I don't know. Yeah, find lets you... I think I did implement this one year. I wonder if I have it in... if it's recent enough that it's on this computer. No. These are all using like actual normal sets and maps. I'm sure I would have called it union and find, or I would have at least mentioned it, right? So, all right. What is... if I look for disjoint set on Hackage... oh, this one isn't on Stackage. I don't totally know what that means. Does that mean I can't have it in a stack project? I'm not sure. Well, I mean, I guess it's easy to find out. Yeah, union find. So I guess we can. Here, I'm back over here now. Just checking whether I had a dependency on that in any previous year that's on this computer, and it looks like no. So if I were to just edit my... Why don't open new Emacs. You're in tmux. Okay. Or just add disjoint set to my cabal file. Does this work? I think no, because it's not on... Yeah. It's not in stackage, and I don't totally know what that means. I don't understand the Haskell ecosystem. I think the way it works is like Hackage is sort of the Wild West. Anybody can publish a package with any name and give it whatever versions they want and do, upload it whenever they feel like it. I don't know if Hackage even runs tests for you and rejects things that fail their own tests, or if you're expected to do that yourself. Stackage is associated with Stack and builds on top of Hackage by regularly, at some interval I don't know about, trying to find coherent snapshots of all the packages on Hackage such that they don't have a dependency version conflict with each other. And so you just say, I want a version of this thing, and it gives you a version that's compatible with everything else. And I guess disjoint set maybe... Like, I assume if they could find a version of it that was compatible with everything else, they would have. So there must be some reason it is not in Stackage. But they say, hey, try putting this in your stack YAML. Why not? I'll give that a try and see if anything good happens. What kind of crazy dependency is this, by the way? This is like, I don't know, whatever. It's something. Stack build? Okay. What is wrong? Oh, I see. It's very out of date. Yeah. So, I mean, these are just... How old is this package? How can I find that out? I don't know how to know that. I can see versions. Ah, there it is. Last updated 2012. Yeah, very funny. Okay. And none of these... So I assume they all have basically the same problem, right? I don't know what the hell unbound generics is. I guess I'll have a look. No, I don't think I want to mess with this. Oh no. Yeah, all right, get out of here. So what if we search for union find? Yeah, so this is the package we were looking for. Union find array. Okay, well, here's another one that doesn't say it's not on Stackage. It's Tarjan's disjoint set forest using mutable arrays. Okay. And there's a pure version useful for querying the result of a union find construction. Okay. That looks cool. It looks like it last built in 2024. That's when it was uploaded. Last year. Uploaded by somebody and then never modded. No, that's not true. I don't know what the difference is between revisions and versions. Okay, no readme maybe? But data union, I guess? Yeah, I mean, this looks more like one guy's project for a particular thing, and less like a I mean, but it's documented. It has documents. It's just not designed to be super duper easy to. There's no like getting started guide or whatever. Okay, so Union is our immutable version. L is labels, I guess. The type of a union is its. And a node is just an int, so we're not supposed to think about these, I guess. Okay, fine. Well, let's look at the index, maybe. Data union st, okay. A disjoint set forest with nodes numbered from 0 which can carry labels. Okay. Why does it want a single L? Isn't that a label? Don't I want a label for each node, not just... What do you mean trying to shrink it will return the same forest? Like, you didn't provide me a shrink function. I don't know what I would do that would try to shrink it. Okay, whatever. So what do you... I think I get it. New is actually creating a node, not a new forest. It says a new forest. Well, I don't know. What's the difference between a node like and a forest that's currently of size 1? I don't know. So what's the merge function take? Oh, you can even combine their labels? So can I just label these all with a size? Boy, I think I'm going to have some stumbling blocks with this API of just not understanding how you're supposed to use this library. But merge takes a single, like, union st is an overarching, this is the forest type, and then you just pass it 2 ints. So I guess I don't really understand still I still don't understand why there's an L argument to new. Because the union ST itself is surely not labeled, is it? Well, it returns to us a union of L. What is a union of L? Okay, it's a union. Oh! I see. It's an array of the labels of every node. But that still doesn't explain why I need to pass a label to... Also, what the hell does UP stand for? I guess it's like all the nodes, or like... Oh, this is like parents or something? Right? Each int points to its parent, I'm guessing, in this array. Like, what... It's an array mapping from int to int. What is your parent? Probably. Which I don't really care about. So what does merging actually do? Do we get back a single node? Or what? Oh no. Okay, it finds this. It compares the nodes' ranks. It writes into up. Yeah, it sets the parent of the... Let's see, if A is smaller than B, then it sets A to be, to have its parent be B. So it makes the bigger one the parent. And then it calls this cont function. And writes the label of U. Oh, right. Because the labels are not stored on the nodes, but on the graph itself. It writes into the graph that Y no longer exists, I think. Like, Y no longer has an entry. Or it no longer has a label because it's not a root, and only the roots are labeled, I guess. And F, I guess, is the function to combine labels. Yeah. Then it writes the label of X to be the combined label. And what is A? I give it a union, a forest, a combining function. Oh, A is just whatever I want. If the merge actually happened, I'll get back a value that I can compute myself by, like, I have to write a function that takes two labels and returns a new label and also any value I want. And then it'll give me back nothing if no merge happened, or the value I wanted to give to myself. Okay. So... look up... So I'll still be able to look up the old node that is no longer the parent if I want. But it won't have a label, which is fine. When I look it up, it'll give me the parent node, and I'll know that node's label. Okay. And I'll get back one of these. And I'll have labels. I don't want. I want. So take me back to data union. Not the ST version, the immutable. What can I query when I'm done with all this? I can look up the representative of a node and its label. I mean, I can flatten when I'm done, which is fine, but I'm just curious, like, what's... The difference is that lookup might be recursive. So in a traditional union find algorithm, lookup, one of the reasons it's fast is if you look up a node which isn't at the root, then while it's traversing the chain of parents up to the root, it also mutates things so that it is now like also at the root. Or that like one level above it is so that its parent link points directly to the root. And I'm sure this version does that too while you're doing mutation operations. But once it gives you back this pure version, lookup can't do that. So if you want efficient lookup of many things at the end, you should call flatten before you freeze it. But sure, okay. So I can get a node, and what is a node? A node is an int. I can get a node and its label. So if I label nodes with their size, then the array that I get back or the union object that's effectively an array that I get back will tell me the size of each circuit, I guess is the word they're using. But I'll still have to find the three I'll have to like uniqueify all of the results, right? Is it ORed and stuff? It is, okay. So I could produce, let's say, a list of pairs of node label and circuit size, and then use like nub ord to at least semi-efficiently remove all the duplicates from that, sort it and take 3, and that would be my answer. This all seems like it should work. This seems like an acceptable data structure. I'll have some stumbles, as I said, I'm sure, but you know, learning how to use a new thing on Stackage, that is a useful skill. You know what, let's just use undo. Great. And then edit the cabal file because I don't understand how Stackage works. What is this called? Union. Oh, I have it copy paste buffer. There we go. Stack build. This one was in Stackage, so it should just work. Right? That's one nice thing about like Maven and the whole Java ecosystem is that you don't have to build stuff locally, and so if it's published, it works. I mean, okay, native dependencies aside, you just download the jar because it's the same everywhere, which is nice. All right, but okay. We now have union find. And let's just check. I mean, not that there's any reason to be concerned, but yes, we can import data union. All right. So let's get going on main, like the actual program, I guess. I need a few things to import. Let's write the parser first. That'll be nice and pleasant, won't it? Data junction, I guess? I mean, really, it's a point. Yeah, I guess this is a better description of a point, isn't it? Or a coordinate. Coord is coord. Int. I don't think I need to derive anything, really. But I guess eq and ord and show are always nice. I kind of need floating point numbers, don't I? I hate floating point numbers. Obviously, you don't have to import those, but I do hate them. I mean, this is pretty much the only thing we need for our input. Our input is just a list of coord, right? And so we can write a parser for that. Import. Do I need text radical duplicative? Yes, it would be great. As usual, it's kind of overkill for a small task like this, but it seems appropriate. There was one day this year that I just did like 1 or 2 days actually where I just did like raw text handling because it was so simple, but I think we will benefit at least a little bit from this. I need match, I need sim, I need sum. Probably it. And I need decimal to parse ints. As usual, my horrible handling of nulls. Classic, not nulls, parse errors. Input is some coord. And a coord is very simple. It's just coord of a decimal followed by an ignored comma, and then again a decimal followed by an ignored comma, and then another decimal followed by an ignored new line. I don't need to keep writing where. There you go. I mean, that's it, right? That's the whole parser. I hope. Yeah, looks good. Easy as pie. And of course I could have inlined all of this, but it's nice to have names for things. So that's the parser. I guess. Because who knows what part 2 is going to be. But this is all the data we're given. So part 1 should take this data and do something part 1-y with it. Let's see. Like, I want to compute like the distance, the pairwise distance between every pair of nodes, because I think we need that, right? Like, there's probably some more efficient way using k nearest neighbors or something. Let me actually look that up. What is the deal with k nearest neighbors? It's more of like a linear algebra thing that I wasn't any good at. And if k, in our case, k could be 1. Oh, maybe this isn't the thing. Supervised learning for classification. Okay, this isn't what I want. Maybe I mean nearest neighbor search. The point in a given set that is closest to a given point. But I don't have that. I have a whole set, and I want to find the 2 points that are closest to each other. Well, of course, most commonly M is a metric space. I don't know what a metric space is, but I guess, yeah, a set and a notion of distance. Okay, yes, you're right. It's a metric space. Who knew? I have a distance metric that's symmetric, and yeah, it's the d-dimensional vector space. Yep, using Euclidean distance. That's me. So, but this isn't quite what I want, right? What? Yeah, like, what are all of these? 'Cause no. Huh. So in all of these, there's like a query point that you care about, trying to find the one that is closest to it. Space partitioning. Oof. All right, so are any of these variants near? Okay, this is maybe interesting. We have n data points, and which is the nearest neighbor for every one of those n points. You could run nearest neighbor for each, but an improved strategy, yeah, there's redundancy between these two. Yeah. Thanks, very helpful. I don't know if I have a semi-definite positive norm. You just said, oh yeah, you can find it. Don't tell me how. Fair enough. Closest pair of points problem? Maybe that's what I'm looking at. In linear time, but I don't even really think this is helpful to me, right? Because once I've connected points A and B, I need to do another search that includes points A and point B, but ignores the connection says don't connect A and B again. So, dynamic closest pair? Oh my gosh, what is this? Yeah, this still isn't what I want because it has insertion, but it doesn't have deletion, I think. All right. So it looks like this isn't exactly a well-known problem that we're solving here. Find the closest pair of things in two, like the closest pair, and then the second closest pair, and then the third closest pair. It doesn't look like that's any of these. Neighbor joining? Oh, maybe that's something. I don't think I have any phylogenetic trees. An unresolved tree. Find the pair of distinct things with the smallest distance. Make a new node join them. And connect that to the center. That's interesting. I don't think it's what I want. But it's closer than anything else has been. All right. So, just doing the naive, inefficient thing for this part seems fine. Compute the pairwise distance for every node, and then sort them, and find the 100 smallest, and then merge those nodes. In our union find structure. It's been almost an hour and I've not written like any code, but it's all about thinking. If you're not trying to solve competitively and quickly anyway. All right. So where are we? I have my list of coordinates. So part 1. Coords? I'm going to start by writing let in, and then I'm inevitably going to change it to a where, but I don't know. I want... It feels more like step-by-step in a let, whereas in a where you kind of have to know what you were writing to begin with. Bottom-up versus top-down, kind of, in a way. So I want... Do I want to put this into a map? Why? I guess not really. Let's see. I want to be a little bit more careful, actually. So label each node, so I have an int for it, which I'll be using to do the union find combination step. Distances is do I p, the index of the first one and the location of the first one, from labeled JQ from labeled And I want to make sure I and j are different, so I guess I need control1 at guard. Because I refuse to do this stuff as a list comprehension, even when it would be easier for me. Guard that I is not j. Then give me pure of what? I need a tuple of some kind. I guess what I want is distance PQ and then I and j as their own tuple. I think that's right. Give me a where, please. Oh, in undefined. There you go. Where. So let's the distance function. Distance of chord A, B, C, chord X, Y, Z, I guess, is squirt of from integral? Yeah. Of a minus x. Do I really want to write a minus x squared plus b minus, I mean, kind of. Let's just write a little go function here. Go xy is x minus y. Yeah, minus squared. Go a x plus go by plus go c. I'm sure there's a better name than go for the squared distance, but I didn't want to write squidist or something multiple times. And we have to write from integral because the type of square root, as you can see at the bottom here, it takes a floating point number and returns a floating point number of the same type. So we can't give it 2 ints and get back a float. It works in the same type. If you want any conversions, you do them yourself. And from integral converts from any integral type to any other numeric type. So we're converting from int to double, I assume. Maybe I'll have to specify that at some point, but I think it should default to that. All right, does this compile at all, you think? Yes. It's defaulting to integer, because I didn't... Yeah, why are you defaulting to integer? You're warning me that 2 is defaulting to an integer? Is that what's happening? I think so. Arising from the literal 2. Yeah, oh, sure. That's got to be some integral, but you don't know which one, so you're picking 2, just picking integer. Fine, I really could not care less. But I guess to avoid a warning, I will tell you 2 is an int. I mean, I could just multiply it by x minus y again, but then I have to save that, so there you go. It's an int. Are you happy? Okay, great. It's unhappy about many other things, but I really don't care that much. All right, these are both ints, so we'll call them n and m, and you'll be happier about that. Now there's some unused things, and I haven't specified what type. Eventually you'll be able to infer this once I use them as labels in a union find tree forest. Okay. So I have all the distances now. Let's... what do we call these? What does the problem statement call it when we join circuits? Become part of the same circuit, connecting. Call them connections, I guess. Okay. So that's actually probably a good enough starting point that we can do a little bit of testing here. Okay, just infer this type for me. Take 10 connections. What are the first 10 connections we're going to make? You have to import sort. What an old language. Okay. So give me main, please. Okay, I'll run it at the command line if you're going to be so slow about it in unoptimized mode. Okay. So it's found 487.017 something. The first two... Well, I'm glad I tested this because these are the same pair of nodes. And I thought I said don't do that. And wow, they are way closer to each other than the next pair of nodes, huh? 487 versus like 1041? Okay, so why did you... Oh, yeah, of course. Yeah, of course I and J are different. You know, you don't want to connect a node to itself. Which is that's all I was trying to prevent. And I forgot that I should also only have each pair of nodes once. So if I just check that, well, wait a minute. Actually, what I should do is guard that I is less than J. You could do this more efficiently by... Yeah, quite a bit more efficiently. By, like, splitting... I don't know exactly. You could get, like... It doesn't matter. This is fine. Oh, we were doing this, the command line. Okay. So then I find 249 and 923 and 130, 136. And their distances are all floating point numbers, and they're all getting bigger in order. So this looks like what I wanted the distances to be. So now... we want to do some stuff in state. Or ST, rather. Which, you know, I don't do a ton, so I always have to, like, remember where all the relevant stuff is. But I think in this case, all I really need from ST is... the type and run ST, and that's probably it. Everything else... Okay, it's happy with that. Everything else... These are the only stateful operations I need. Everything else is going to be using operations from union find or whatever it's called, data union. I guess I, in this series, haven't said explicitly what ST is. ST is... So Haskell is a purely functional programming language. You can't mutate state. without cheating, unless you say you will. So there are some cheats for like doing stuff in development or whatever, but you're not supposed to use them generally. And ST is not cheating. ST gives you kind of a sandbox where within that sandbox you have access to mutation, but the compiler proves that nothing mutable can ever leak out of that sandbox. And so if you get a value that was computed using ST, as far as you're concerned, it's immutable. It'll never change. And so you have to tag every place you're using that, and it makes sure even that two different ST sandboxes don't leak into each other. They're distinct. So any computation using ST you could do purely, but ST makes it more efficient because it actually does do mutation under the hood. And then in our... we need data union ST. What all do we need from this? I probably need a union... oh. Maybe I don't need anything from control monad ST. Let's comment that out for now, because it gives me run union ST. Yeah, which produces a union object. It does all the mutation. Okay, so I definitely need new to make a new node in the... or to make the new thing I want to run. I've already forgotten. Is L the array? Sorry, I'm looking at this stuff. Is the L here the type of labels, or is it the type of an array of labels? It's the type of a label. I still don't know why... I knew how this worked a while ago, and now I don't anymore. So new... an int? Okay, so what the hell is this? Oh, it's the default label. Oh, God, I would have loved some documentation on this. Okay, so we're initializing each node with this label, which will be 1, I guess. I see. All right. So we need new. I don't need grow. I don't need copy. I don't need lookup or annotate. I just need merge and flatten. And I guess unsafe freeze is the way to get back in normal union? No, I have run st. So I need new and merge and flatten. Actually, does run... I bet run union st flattens it for you, right? At the end? No. Alright, so I'll use flatten as well then. And in data union, I need... I know the size. I guess I'll use lookup flatten because I've promised myself that I will flatten at the end. Lookup should be almost as efficient, but we're skipping. We're skipping one equality comparison. I guess. Maybe, just in case, I will use the ordinary lookup. I do not need efficiency in lookup flattened. And if I handle things wrong, there's some chance this will be incorrect and this will be correct. So I just need lookup, basically, right? Well, I need to know about the node from node, I guess, as well. Yeah, I think those are the only things I need from data union. Let's see. I need some more things to let here. Size is length of labeled, the number of nodes. And we can out here, I suppose, find merges is take 1,000 connections. Oh, I already have them. They're connections. Great. Let's put this up here. So I want... Well... I guess I can do this in the let as well. Connected. Run. What's this function called? Run union st. Yeah. Of do. Well. Yeah, I do need it in do, I think. Okay, what's the type of run union st? It just takes an STS of a union st and gives you back the thing. So, yeah, all right. I think I need do at this point. Forest is new. Maybe I should import this qualified? New is the only one that I really don't like the name of. I guess I'll leave it. New of, and what are the arguments to new? An int, which is capacity. That's size. Then a default label, which is 1, the weight of each subtree. And that's it. Then it gives you back an STS of union ST. Great. How does it determine what the labels are, actually? Okay. It chooses the labels itself from 0 to size -1. That's fine with me. I'll use those labels. Okay. They happen to be the labels I'm already using, so great. But if I wanted different labels, too bad, I can't have them. All right. Then I think I can just say traverse. Let's actually write 4m because I want to end it with a lambda. 4m connections do. I don't think I even need a do, but I'll put it there for the moment. So for each connection in the connections I'm planning to make, no, it's not do. It's lambda of... Do I need parentheses here? I don't really know. I don't think so. Lambda of... And what we put in our connections list is a distance, which I don't care about. And then the two node labels, I and j. And then I just want to merge. What arguments does merge take? It takes the forest first. A merge function. Add, I guess. No, I'll just write the lambda here. X lambda lambda x y x plus y, and then I do not care about what I don't care about the result, so I'll just return unit. And then it wants I and j, like that. And that's it. Then I can, I think, just say flatten the forest. Pure forest? I think so. Because run union st wants an st computation that returns a union st of s and that L, and then it gives me back the union. All right. So now connected is my forest of stuff. My merged, we have connected the 100 things, the 1,000 things that are closest together. And they will each have their own, each node. Okay, so now I have a union of int because the labels are ints. Size, lookup flattened. Okay. Kind of annoying that there's no like bulk lookup, but whatever. So let's let represent, well, they're sort of circuits, really, right? Circuits is lookup connected. Oh, I guess it's going to be upset that I'm shadowing the lookup from Prelude, but that's fine. Lookup connected n for n in 0 to size -1. So what? No, this isn't quite what I want. Because this is going to give me a node and a weight. Okay, so... Oops. Yeah, see, this is why I like do comprehension so much better. It's not why, but it is true. Let I guess node weight be this. And then I want to nub ord this, right? To get the unique... Yeah. The unique set of things. I'm going to need that in... Where is nub ord? Data list, maybe? Is it not anywhere normal? Data containers list utils. Are you kidding me? We don't have this anywhere in the prelude? Or in like an included I mean, I guess containers is included these days. Okay, fine. Data containers list utils again. So nub is a function in the classic like Haskell, the first draft language of Haskell that, you know, takes a list of things and removes the duplicates from the list. But because it only has an equality constraint and not a sortable constraint, the best it can do is the n-squared algorithm of comparing each item to each other item. And so nub ord does the same thing by basically putting them into a set and then giving you back the values. I mean, it's not exactly that, but roughly. So it's a more efficient way to remove duplicates from a list. And I guess here I actually do just want to return, and I just want to do this. I just want to, okay, so it was supposed to be a list comprehension all along, huh? But I just wasn't sure what order things would be in. There we go. Okay, where were we? Now I have all the circuits, and I want... It wants me to multiply the top 3 biggest circuits? Yeah, okay. Well, some... Nope, not some. I'm so used to writing some. Product of map second of take 3 of circuits. What do you think? Compiles? Lookup is ambiguous. Okay, fine. Annoying. I don't need this anyway. That's nice. Let's... specify we don't want the one from Prelude. 4M is not in scope. Oh, you're right. I forgot to destructure. I knew there was a reason I needed to... okay. 4M is... data.traversable, maybe? Data foldable. Okay, fine. Also control monad. Interesting. Why? I mean, I don't know. I guess 4M has a monad constraint because it has since time immemorial, but you could do it with traversable these days. Or applicative or something? I don't know. Yeah, wait, what? Okay. So here's 4M, right? Takes a foldable T and a monad M. Yeah, so like a T canonically usually would be a list, and M would be some monad. Takes a list of objects and a way to turn that object into an action, which it throws away the result of. But this is the same type as traverse, but just in a different order, right? Okay, so it's still... right. 4M needs foldable, not list anymore. but it takes applicative instead. This doesn't require traversable? Oh, is that because I have an underscore? Yes, I see. Because I'm throwing away the result, you don't need to be able to traverse the original structure, of course. And 4M also needs a traversable, but it only needs foldable if you do this. I see. Okay. So anyway, data... well, I see. And that's why it's in data foldable instead of data traversable. Makes sense. So actually, instead of from node, I'm going to say I want node and its constructors or slash fields so that I can... Nope. That doesn't help. What? Does lookup want a node, not an int? It does. So I have the opposite problem also. Alright. So I actually do just want all of this shit. Because that would give me from node as well. Accidentally scrolled to the bottom of the screen, I guess. So make a node, look it up, unwrap the node. And we're calling fmap from node because the... No, it's not even right. Okay, I hate this game. Alright, we're back to do, baby. Nobody can stop me. Let... no... well, n weight equal this. Pure of from node n. Actually, I'm gonna just do this. How about that? It compiles. Your defaulting distance. Okay, sure. I'll give you a type signature on distance, I guess. Because that is what I wanted. $78. That seems very small. Does 78 even have 3 factors? What is it? It's 39 times 2? Which is 13 times 3 times 2? I mean, that is possible. We have 1,000 connections in 1,000 nodes. I think this is going to be too small, but I'll submit it. That's not the right answer. You won't even tell me if it's too high or too low. Fair enough. All right, I'm going to go take a break, and then I'll tackle this when I get back. All right. I'm back. So, we have some debugging to do. I guess, like, one of the first things we could test would be just running it on the example input. And then I can see, like, all of the circuits, not just 3, and see if that's helpful at all. So, kind of annoying that all of this is locked behind part 1, which is hard-coded to run exactly 1,000 connections somewhere. Yes. So I guess I will just extract this as a function. And part 1 we'll call it with 1,000, and I'll call it with something else to run my little test. Connect int input actually I want to return the entire forest, I think. A pair of int and int, I guess. A list of pair of int and int. Connect num connections chords equals and instead of this I will just return the circuits, I think. Yeah. And then we can say product map second take 3 connect 1,000. Let's see if we still get 78. Nope, doesn't compile. Size. Oh yeah, my indentation is all wrong after that. After moving that. At this point where it's like in circuits, I feel like I could almost stomach turning this whole thing into a where now. But whatever, I just won't. Okay, same wrong answer. Good. So now we know we've preserved that, and I can say connect 10 prepare read file test input.txt. Huh? No, I didn't reload. Okay. I don't think this is anything like what I wanted. The sizes are all wrong. But let's look at the circuit numbers, right? This is circuit number 1, which seems to have 7 things. Is that what we expected? No, it has weight 1. Okay, what are we expecting? We should have one circuit with 5 boxes. 7, which each contain a single box. So that much has worked. We found 7 disconnected circuits. A 5, a 4, and 2 2s. Oh, maybe this is right. A 4, a 5, and 2 2s. Oh! Am I sorting this wrong? I am. I should have put the weight first because I want to sort by that. But I guess what I'll do instead is it sort. I always forget what sort by versus sort on. I think I want sort by. Yeah, sort on. No. Sort on applies a key function to each element. Yeah, that's what I want. Okay. Sort on. Am I not sorting them at all? I know I'm sorting this, but I returned the circuits. Oh, I just picked 3 arbitrary ones and said these are the 3 best. I assumed that I had sorted them at some point, but I did not. Okay, well, I want the normal sort anyway for this. So I guess I will put the weight first. And actually, no, I don't have to be so foolish, because I don't actually care about the node labels. I can just look at the weights, which means I can put this map second here, and then sort. Right? Connect 1,000 things, get just the weights, sort them, take the top 3, and multiply them. And that actually shouldn't change this result at all. But now... 20. Oh! Wait. Oh, that's right, because this is the test input, right? No, it should be 40. So we should get a 4, a 5, and 1 of the 2s. Okay. So, okay, what about this nub-ord bit? This is correct, because I still am including the node IDs here. If I have like a circuit with 5 things in it, there will be 5 different things that return the same result for lookup. They'll return their their representative number index and their weight. So nub-ord throws those away, and we only get 1 of the 5s. In fact, we can test this real quick. If I replace this with just identity, we can see that the 4 and the 5, 19 and 4, 18 and 5 both show up multiple times, which we don't want. So that's what the nub-ord is for, and it's working. So this entire connect function is working. Somehow part 1 is wrong, despite being so simple. Oh. Part 1 is wrong because it's connecting 1,000. Okay, got it. But this, connect 10 to upper pair mapped over this. I mean, it gives us the right list. And if I said this, oops, right, you can't copy paste like that. You have to do it like this. 1. 1? Oh, map. No. Oh. The weights are first now, not second. Wait, really? No, the weights are second. Oh, but sort gives you the smallest elements first. That explains why I got such a small number earlier. I want the largest. So sort by down, I guess. Put this here. Which I must import. Oh, I guess I may as well import in the real file. Import. Need sort by as well. Sort on, not sort by. I just looked it up and I still can't remember it. Right, sort on. 40. Okay. This number is much more plausible. What are its prime factors? Well, it has at least 3, I guess I can say, right? It's divisible by 4 and by 5, which means it's divisible by 2 and by 2 and by 5. So there certainly are at least 3 numbers. Well, no. You could get this by just multiplying one region of size, but like, whatever. Actually, there are only 1,000 nodes in the network, right? And this circuit, therefore, can't be all of them. It would just be size 1,000. So what is the cube root of 47,000? Obviously, that's not exact, but like that would tell us roughly what are the size of the 3 circuits. Like the square root would be 7. Square root of 49 is 7. I don't know. Let's just submit the number. That's the right answer. Okay, good. Let's get this committed. And I think I just will probably want to commit all of this. I don't think I have any outrageous stuff left in. Yeah, I don't love connect. Let in is not very fashionable. Everybody loves wheres. But I like it here. This feels more imperative, which matches kind of how I feel like I'm doing this. Day 8, part 1. All right, what's up with part 2, do you think? The elves were right. They definitely don't have enough extension cables. You'll need to keep connecting junction boxes together until they're all in one large circuit. Continuing the above example, the first connection which causes all of the junction boxes to form a single circuit is between the junction boxes of blah, 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 blah. They need to know how far those are from the wall. I see. So we continue doing this in the same order until there's only one thing left. That is, I mean, mostly fine. I think we'll want to parameterize our connect function. Currently it takes an int. We'll need it to take something more flexible to decide when to stop. Let's see. What is the type of fold M? I mean, this is just... No, traverse is map M. Works left to right. Yeah, and we can't... We can't stop early with fold M. So I want to iterate over a list performing a stateful operation until I decide I'm done. What effect is that? Is that maybe? Well, maybe it's either. Because, yeah, this is in some sense an error, right? I want to fold over a list until an error occurs, and the error will be I'm done. And I can throw the error saying this is why I finished, in a way. So do I want error T? It doesn't look like it. I guess I want accept T. Yeah, this one's everywhere. Oh my god, there's so many. This one. So run accept T. It's an M, which in our case would be ST, of either error or the type we are finished, the type of normal values. So I think that's what I want. Because I want each value in the list to have the capacity to either abort the computation with a value or perform some stateful actions. So we want a monad transformer there. And I'll just use like lift. I mean, MTL is more convenient, but I kind of like the extra clarity. For small monad transformers, like I end up sometimes using in Advent of Code, I prefer the extra clarity of transformers, even though it's more ceremony than you get with MTL. Okay, so I think I want accept T. Where's my ST stuff? Here it is. And now I can't just use run union ST, can I? Oh, maybe I can? because if I run except t, I'll get back an st of either. Well, but the issue is I don't want, for part 2, I don't even want the tree back, right? I just want the last 2 nodes. I don't even have... I don't even have like an efficient, not that the efficiency is super important here, way to look up for a node index what is its position. I actually have to look it up by indexing into the original coordinates list. Kind of funny, but fine. So, yeah. This is a little specialized part 1 in a way that I don't know how to untangle properly. So here's my stateful computation. It's just this. And I can basically, if I want, like take a function that says what to do, here, after you're done merging. If there's just one thing left, or if the size of the merged node is the size of the forest, then return, like I can have this be a maybe that returns just the answer when the forest becomes united. The question is how to smuggle like both the part 2 and the part 1 answers out of this, because part 1 wants to continue when all of the ST stuff is done, and part 2 is like, I already have the answer, leave me alone. Right? So, I mean, I guess like part 1 won't ever get to the point where these two have been joined. This is not a very elegant solution, I don't think. But we could just have this function. No, but the problem is it returns the graph, which is not what we even want. So maybe what it should do is take... maybe it can just return either the graph when the connections you gave it are done, or the coordinates of the last two nodes to be connected. And part one will assume, it will check, but part one will get the left value, or the right value, I guess, and part two will get the left value. It does not feel very pretty to me at all, but either two coordinates or a list of pair of node indices. So run union st assumes it's running in st only, correct? Where yes, it just runs a, which it assumes to be an st value, and then calls freeze. Okay, so I can't use that anymore. We have to do a more complicated st computation. And I guess that means we have to call unsafe freeze ourselves? I guess it's unsafe because if we continued using the union object when we were done, there'd be a problem? Sure. Because it's unsafe freezing the arrays that it's using. Okay. So get rid of this. Give me unsafe freeze. Accept? Is that the one I said I wanted? I know it was, but like, what's actually the name of its control monad trans accept? Yes, okay. I want run accept for sure. And I think I just want, it'll be exporting lift for me. Is that true? Oh, let's use... No, okay. I guess I don't need lift because I can just use pure. Right? No, because pure would bypass both of these. So, okay. So we have throw E, which, sure. I think that's the same as just left. In a way that I don't totally understand the difference. And I guess the point is it's giving me lift because it's an instance of monad trans. Yes, okay. Got it. So do those all even import? No. Lift is from control monad trans class. Okay, now it doesn't compile because I deleted some of the stuff I need. And I changed the type signatures and stuff, but the imports work. Which is what I wanted at that moment. So I want run accept. Oh, I want run accept T, excuse me. That'll return an st of either error or thing. Okay. Run except t of do. And so anytime I want to do a stateful computation, I need to do lift, right? Or is it the opposite? Let's see. Lift, it must be this way. For any other monad, I can lift an operation from that monad into except t by calling lift. Okay. So lift, making a new thing. It'll give me back an m of either. So I think actually I should say run st of... And I know you get into some trouble if you try to compose run st in the same way you compose other functions because it has funny types. So I think you're supposed to do it like this. Run st of run except of do. So lift making a new thing. And then I want to iterate over all the connections. And I think 4m is right. Except no. Right, I don't want to just lift a merge. Exactly. I want to, let's see. I guess I want result to come from this merge. But this function should be different. Let's put this in a where. I can't call it merge. Like, what the hell can I call this stupid thing? Union? Sure, I'm not using that name anywhere. Union xy is new size something. Can I write an if here? I can. I guess it's my best idea. Where size prime is... It's just x plus y. If size equals size prime, then we're done. We have completely joined up the forest. Then we must return left of x and y, I think. Well, we might as well look these up in the coordinates. Coords x and coords y. Else, right, nobody cares. Oh, and this shouldn't be left, it should be throw E. And this should be pure unit. So this throw E is not like an exception in Java where it's blessed by the compiler and will immediately break in the middle of things. It's just an ordinary Haskell value that the accept monad transformer knows to handle specially. But it can live in other, in other contexts. And indeed it will here for a moment, because here, when I say merge forest union, it's going to return to me a maybe of either of ST or something. Oh, God. Let's see. I think it's going to return to me an STS. Okay, we actually do want to lift this, I think. Because this is in... For each connection, I have a stateful computation that doesn't do any ethering because it can't. So I think I actually have to do lift here, because I need to do some stateful computation. And it'll return to me that means result will now be a maybe of an error, or a maybe of an either, which could be an error. So funny enough, I think I want to sequence the result, probably here. So that I look inside the maybe. If it was nothing, then nothing happens. If it was if it was a just value, I lift that, I invert it, so that instead of a maybe of a maybe of an either, I have an either of a maybe. And if that either is left, we will throw its left value, because that's what left does. I think that makes sense. So now, I think what I can do is, at this point, if this returned an error, we will have stopped all the connecting and returned a value. We'll skip this, and we'll be out here with an either value. We'll have done all the state. And I think what I can just do then is fmap this nubord thing. Fmap uniquify connected. No, The problem is connected. Okay. Let's call this a result because it might not be connected. We'll say uniqueify of the connected results is uniqueify is a function. That gets past the unique stuff if it was there. Okay. I have no confidence that this is right, but I'd like to see what the compiler thinks. Illegal lambda syntax and pattern? Explain yourself. There's no pattern there. What do you mean? You're just pointing there. And you're like, that's wrong. And I'm like, no, it isn't. That's just a lambda, dude. What do you mean? Yeah, so I'm just kind of testing how Emacs indents this stuff because that sometimes indicates that my understanding of the source file doesn't match with the compilers. But this looks right. What do you think a pattern is here? I mean, this kind of screams you've indented something wrong, I think. But what? I'm in a let block here. Let xe, let blah, 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 blah. Result equals a thing. Run as t of run except t of do. I'm lifting new size and binding that to forest inside of my do. I'm iterating over the connections. I'm calling for_m on the connections and not binding it to anything, which is fine, that's allowed. And I'm passing for_m a lambda, which was fine a minute ago. So I'm lifting a merge, which means I'm doing a stateful operation. And then in a way, am I just doing sequence A on this merge? Why am I lifting it? Okay, but that's not related to the current problem. I don't know what's wrong. What pattern do you think is there? Do I need to indent like this? Surely not, right? No, that doesn't even make sense. Oh, wait a minute. I don't have a do here, actually. Is that what's wrong? I think that was wrong. I don't know if it's the thing that was causing the error. Because now I'm doing two things here, and maybe it's getting confused by something else? Yeah, that looks better. Yeah, I don't have run st. What do you mean size isn't in scope? Oh, because I moved it to a where clause. I moved this union function to a where clause. So it kind of has to be in the let if it's going to make use of other stuff from earlier in the let, huh? That's true. What else? Yeah, some type mismatches. Okay, this one is probably exciting. The second one is just because I haven't updated part 1 yet. So what's the issue here? You thought there'd be an accept of coords of st of something, but actually there was just an st. So I think this is to do with my lift issue I was talking about. So merge returns an st of either something. I think I can just actually say, I shouldn't have said lift. I think I can just say sequence a the result and get rid of this do after all. No, because I have to sequence A again. Because I don't have a, okay. I don't have, like I just said I don't have an st of either. I have an st of maybe of either. So when I call lift merge is a stateful operation. I lift it into accept t with lift. And then when I bind it, result should be a maybe of an error. So when I sequence A that maybe of error, shouldn't I get an error of maybe? What's wrong with that? You're saying you have a maybe of error, but you just wanted an error. You expected an STS of an accept T, but you have... Actually, wait, I haven't even gotten to... You haven't even gotten to the point of me doing the sequence A on the maybe. You're upset about the lift. Oh, whoa. This... Wait, is this right? Am I not where I thought I was in the sequence of undos? Oh, this... Lambda dist... Okay, yeah, in this... You are upset about the sequence A. Okay. Fine. Maybe I don't understand the sequence A. Let's case result of nothing. Let's just do nothing. Just... Well, actually... Just left E. No, but now I don't... I called throw E, right? Like, I called throw error. I don't necessarily have a left. I have some weird thing. So this should work, right? Because if I have a just that's an error, then I'm exposing it, right? I think this is the same as sequence A in a way, but maybe it's different in some way. It looks like it actually is, because I have one fewer error than I had before. Okay, I don't totally understand why that's better, but fine, I'll take it. I think, isn't that what sequence A does? I don't know. Okay. Oh, I didn't lift all the other operations. Specifically this one. What does this mean? What are you upset about? You're saying... I just inferred your result had type anything. But actually, it should have had type... the type I actually wanted it to have. The inferred type of result is A. Okay, well that's not right. Result should have a more specific type than that. Result should have type either... I mean, it should have the type I said it should. This. Because I'm just returning this, right? No, not quite, am I? Because I'm calling uniquify. Okay. Maybe if I give uniquify a better type. Takes a list of no. Takes a union of int and returns a list of pair of int and int. I'm probably going to have to mention the type union for the first time now. Is this any better? No, you're just still saying result should have any type at all. I don't understand why you think that. So I have a very simple run except T. It's just 4 statements, the last of which is a return. Weird, by the way, that I wrote return. I usually write pure. Wait, I did write pure. Why have you written return? Lift, flatten forest. There's a pure right there, you sicko. Is that because of applicative do? It is. Applicative do rewrote this into a return for some weird reason. Okay. So you thought it should be able to return any type the caller wants. That's crazy. How did you infer the type of A? You inferred it for result. Okay, I mean, I'm going to keep telling you where you're wrong until you tell me why you thought that stupid thing. Result should have type either a pair of coordinates or a union of int, please. Oh, okay. I forgot. I have to call unsafe freeze now, because I'm not using the run union st anymore. Okay. Well, I wish you'd given me a more helpful error message, but let me just make sure. Oh, okay, I'll just. Now we're maybe getting somewhere. Oh yeah, I have to like lift that. Okay, got it. So now this connect function compiles. Yeah. I was returning a stateful value, like st of st. Or I was returning a union st instead of returning an ordinary union, forgetting that I had changed to use run st and unsafe freeze instead of run union st. Okay. So I can finally get rid of these type signatures that I don't really want anymore. Distance I do need because it's specifying double. Okay. I don't. What does from right do? It's like cheating. It says, yeah. It just assumes there will be a right value, and it throws an error otherwise, which is what I want, I guess. Is there a from left? There must be. Yes, okay. Well, let's make sure that part 1 still works. What do you mean it's applied to too few arguments? Oh, no, it doesn't make that assumption, does it? It says, give me... Okay. Right. it says, give me a value to use in... Wait, what? What? This type looks crazy. Isn't this stupid? No. Oh, right. It says, give me a value to use if there wasn't a B in this either. And then I'll give you a B, either the one that was there or the one you gave me. Right. So I guess really, I mean, isn't that... Yeah, fine. Undefined. That, I think, is the same number we had before, right? Yes. So I've managed to tread water as far as part 1 is concerned. Hopefully this involves some progress in part 2. Connect all million of them. Let's get a right. And then what is it they want from me? The product of the x coordinates of the junctions. Okay. Which they call the distance from the walls, where wall distance of chord x chord A, I guess. Oops. Is A times X. It's a lowercase c. Oh, yeah, wall distance takes 2 args, so I guess we need to uncurve it. All right. It's a product of 2 numbers. It's very large. Really? A million? I guess if the coordinates are about, on average, 2,000. Let me just check the input file real quick. Yeah. I mean, sure. The x coordinate... I mean, actually, that would be kind of surprisingly low. No, it's 400 million. So that would be on averaging like 20,000, which, yeah, that seems like about in the middle of the range here. Let's try this number. Too low. Well, tough to do anything with too low. But I guess I can run the tests, the test input at least. And I assume there will be something wrong. Oh, I actually do kind of need to replicate, because part 2 won't be correct. It'll say to connect. I guess that's fine. Yeah, part 2 should be fine. Because it just says, you know, keep going until there's nothing left, right? 24225. Okay, well, that's wrong. So that's good. We can test it in a small context. Wait, did I just write some total nonsense? What? What, what numbers am I actually returning from this? I'm calling merge forest union, passing an I and j. I think what I'm returning is something insane. Where's the union function? Yeah, this doesn't make any sense. I'm multiplying together, like, the sizes of their subtrees. That's crazy. X and Y are not the node numbers. Okay. So how do I get the node numbers? I can't get them in this inside of union. I just have to return, like, a bool, basically. Yeah, that's fine. Yeah, that'll be much simpler, actually. I can just do this. Return the new size, and if it's equal to the old size, and whether it was equal to the old size, basically. Actually, I could just use plus, but then merge. Like, I would then have to look up what's at I and see if it's the right size. I think it's just kind of nice to return, like, true if we're done, basically. So now we can say, if it's just true, then we throw E of I and J. And otherwise, if it's either nothing or just false, we can do nothing. And for once, an excuse to use lambda case. There. Amazing. So we'll lift... Oh, the dollar sign's going to be wrong if I'm not careful. Yeah, lift, merging, and then inspect the result. If it's just true, we'll throw an error indicating the two nodes in question. But it shouldn't be I and J because those are ints. It should be coords I and coords of J. Okay. It still compiles, which is exciting. And it's a number. This one was 400 million. This one is 4 billion? 9 zeros? That would be like 4.5 zeros on each of my inputs. Is that right? Yeah, probably. But I can be a little bit more sure than that if I run part 2 on the test. 25272. That's the answer that they say I should have. Okay, so that's better. Boy, imagine multiplying together the sizes of 2 trees. Okay, that's the right answer. I made it. Okay, it was a bit of a slog today, but it always is when I'm figuring out how to do stuff with ST and looking up new libraries as well. Made a bit of a mess, but in the end, I mean, I don't know. Is this the worst program anybody's ever seen? I don't think so. It's not exactly beautiful. You don't love a humongous function like this. But it is broken up into pieces, in a way. They're just pieces that aren't exposed to the outside world. Yeah. I don't think this is so bad. Oh, you guys can't even... I didn't switch back to viewing. Anyway. Here's the function that I was claiming isn't so bad. You know, it's a big function, but it's in pieces. They're hidden as opposed to being exposed, which is nice, I think. Maybe? Depends, I guess. Less reviewable that way, but also that it doesn't contribute to API clutter, I guess. I don't know. It is... Yeah, I mean, the pieces it's broken up into are, like, referring to the closure. So they are all kind of intertwined in a way that is not that appealing. Oh, well. All right, let's get this committed and get out of here. Yeah, get out of here, applicative do. Nobody wants you. Oh, there was, it was saying I don't need the union type. Anything else? I don't need sequence A. Yeah, wait, why was that wrong, actually? So my understanding is that I had sequence A. I had a just of a left 1. Shouldn't this be left of just 1? Left of 1. Huh? That's wrong. That can't be true. That's because... What the hell? Oh, well... Right, because I'm throwing away the result with sequence A underscore. Oh! No, but that's right. I wanted to throw away the maybe wrapper. But the 1 stuck around, right? The left 1 is still there, and I threw away the just. Either a number or nothing. And the number there was not actually a number. It was the thing I was trying to throw, the result of... So I don't understand why sequence A didn't work there. It's something to do with how the monad transformers stacked together made my situation different from actually being a maybe of a left. I mean, it was maybe of an accept T, and I thought sequence A of that would give me an accept T of something. But I guess it wasn't right. Okay, whatever. Oh, and then I have all these undefines at the bottom. Yuck. And this either. Oh, yeah, I hate this function, actually. The implementation isn't the worst in the world. I hate the API. Yeah. All these from rights make me sick. This is why you should never review your code while you're committing it. Just hit commit and flush it out of your mind. Day 8, part 2. All right, I'm out of here. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.